Hi, my name is Travis with Kaiser Permanente, and this is a preview of a design session we're doing on HVAC engineering. So this little video is the top 5 HVAC design issues that we deal with regularly, me and my team. Issue number one is that we want to see your load calculations, and we really want to participate in your load calculations. We have some information we can share on internal loads and occupancies and usage factors. We've actually done and published research on plug loads, so we want to participate in those. And we do have expectations. We know what cooling load ranges are supposed to be and what heating load ranges are supposed to be, and we want to talk about systems that fall outside of those ranges. Item number two is ventilation calculations. One of the conversations that always blows my mind is when we ask a design engineer for ventilation calculations in schematic design or even DD, and they respond by saying, we're going to do the standard 62 calculations during construction documents. That still blows me away. I don't think this takes a ton of time to do. We know what they need to look like. We have some clear expectations around it, so we need to just be able to get it done. For hospital air handling units, ventilation calculations are much more complicated and way more important. So we really do want to go into detail on these calculations. The calculations you show the state are really just a subset of what we're looking for and what I think a good design entails. So I talk about having room by room and system calculations for 3 conditions. There's the peak condition, the minimum occupied condition, and the minimum unoccupied condition. Energy consumption in hospitals is almost entirely a function of the design minimum of your air handling system. So that means VAV has to be par for the course. In California, that has its own challenges. But we want to see that minimum occupied number down around 0.4 CFM per square foot or below, which corresponds, by the way, to an energy use of about 100 kBTU per square foot per year of HVAC energy. One thing that we ask for, which is kind of unique, are these 8,760 line calculations. Basically, you take your design load calculations for every hour of the year and you really scrutinize it. If you've never done this, I say it is a life-changing experience. It's very common to hear a design engineer talk about boilers that can do 10 to 1 turn down, but then you look at some of these calculations and scrutinize it and find out that you need more like 500 to 1 turn down. And we want, the goal here is that we want our designs to be highly stable and highly energy efficient at the most common operating conditions. And frankly, yes, it is often okay or even smart to sacrifice peak efficiency for knock it out of the park efficiency at your most common operating conditions. Finally, we ask for acceptance criteria. We've been asking our design engineers to write acceptance criteria for about 2 years now. And when we started, designers really didn't know how to do this. But at this point, we have some very good templates. We have all the ones that have been issued on the job so far. So we can really help design engineers get through this hurdle. This is the single most important thing that a design engineer, HVAC design engineer, can do to facilitate commissioning. To place a set of objective and measurable criteria on the expected system performance into the specs and into everybody's contracts. That removes all opinion from the commissioning period, which is insanely valuable and very necessary. And then controls design. We've actually been experimenting, I'll say, with controls design business models. 2 years ago, I would have told you that the engineer of record has to put controls drawings out and a written sequence of operations out in schematic design, really once the systems are selected. But I think we've learned that that may be the worst model out there. Primarily, we don't know any design firms that have controls programmers in-house, and we know only a few design firms that have dedicated controls designers in-house that do controls design 40 hours a week. And so the ideal model is more of an integrated model where the engineer of record, the commissioning agent, the controls integrator, and all the major equipment manufacturers collaboratively author the controls design and the sequence of operations. So where we can make that happen, that's what we're doing. I think we've learned the hard way. If there's a rooftop unit on the job or a factory chiller on the job, then we got to have that vendor write their own sequences. And then we've had jobs where the controls integrator provides the sequence and the engineer supervises that. That works fine. We have jobs where the commissioning agent writes the sequence or supervises the writing of the sequence. That seems to work fine. But it's always got to be a multi-party. We have to maximize the use of specialists within the process of this design. And we really want to see that within the design process. So what I've been doing is spending some time with our HVAC engineers to talk through these issues. If you're a consultant that does casual work, the best thing to do is to schedule this for about an hour, hour and a half, or up to a 2-hour time block. There's a longer version of this presentation. We can do a deeper dive on design tools, what your firm may be using for design and what we're using to check the stuff, and align everyone's tools and align everyone's expectations and go from there.